So we saw in the last several lessons that if we've got f of x equals 10 to the x, then f inverse of x is equal to log to the base 10 of x. Well, what if you have f of x equals a to the power of x? Well, what you get is the inverse of f of x is simply equal to log to the base a of x. And I think one of the best ways to become used to thinking about logs is to see that the information which is expressed by writing a log of something to some base can also be written in exponential form. So let's practice that a little bit. So here we've got log of 100 to the base 10 is equal to 2. Well, that simply means, by definition of logs, that when 10 is raised to the power of 2, you get 100. So in exponential form, you can write 10 to the power of 2 equals 100, and that's saying the same thing as what this expresses, log of 100 to the base 10 is equal to 2. Now, we quickly move on from using the bases of 10 to using other bases when we consider logs. So here you've got this expression, log of 27 to the base 3 is equal to 3. Well, in exponential form, it simply means that the base of 3, when it's raised to the value of the log of 27, which is 3 here, it yields 27. So log of 27 to base 3 equals 3 means 3 raised to the power of 3 gives you 27. That's the exponential form of the same information. This next one here is interesting. You've got log of root of 27 to base 3 is equal to 1.5. So 1.5 is the same as 3 divided by 2. And if you just consider the definition of logs, what this expression is saying is when you take 3, the base, and raise it to the power of 3 over 2, you should get root of 27. And you can see that. 3 to the power of 3 over 2 can be written as 3 to the power of 3, and that whole thing to the power of a half. And 3 to the power of 3 is 27, and that whole thing to the power of half gives us the square root of 27. And then we see here a base of 5. So up until now we saw the bases of 10 and 3. Now we see a base of 5. So the expression log to the base 5 of 1 over square root of 5 equals minus half says that the base 5 raised to the power of minus half, it's hard to see the minus here, the minus sort of blends into the line that separates the numerator and the denominator, but there's a minus here. So the base 5 raised to the power of minus 1 over 2 should be equal to 1 over root of 5, and that it is. Root of 5 can be written as 5 to the power of a half, and since root of 5 is in the denominator, you can write the entire expression 1 over root of 5 as 5 to the power of negative half. So what we see from this exercise is this information that 10 raised to the power of 2 equals to 100 can be expressed using logs, and vice versa. If the information is expressed using logs, we can apply the definition of logs and write the expression in exponential form. They're equivalent. So let's practice that, going from the exponential form to the log form. So we've got the first example, 2 to the power of 2 is equal to a 4. Okay, in log form, what we would say is the base has to be a 2, and then if we take the log of 4 to the base of 2, that value is equal to 2. So what this is saying is when the base of 2 is raised to the power of 2, we get a 4. Again, from exponential form we went to the log form, and it's telling us the same thing. The two forms are equivalent. Now in this case we've got 5 to the power of 3 is equal to 125. In log form we would say log of 125 to the base of 5 is equal to 3. And remembering the definition of logs, what this means is 5 raised to the power of 3 gives us 125. Again, you see the forms are equivalent. So then let's go on to the next example. Here the exponential form is 4 to the power of negative 3 is equal to 1 over 64. Well, in log form, this would be written as log of 1 over 64 to the base 4 is equal to negative 3. So we see that the exponential form and the log forms are equivalent. And here I present to you some examples where we've written the log form, and what we want is the value of this expression. So what is log of 0.04 to the base 5? Well, 0.04 can be written as 4 over 100. 4 over 100 is 1 over 25, and we see that 1 over 25 can be written as 1 over 5 squared, and 1 over 5 squared can be written as 5 to the power of negative 2. So log to the base 5 of 1 over 25 is equal to negative 2. And then the next one, what is log of 64 to the base 2? So to what power must be raised 2 in order to get 64? Well, 2 must be raised to the power of 6 in order to get 64. So log of 64 base 2 is equal to 6. And then the next one, what is log of 1 over root of 2 to base 2? Well, 1 over root of 2 is the same as 1 over 2 to the power of a half, which is the same as 2 to the power of negative 1/2. So what is log of 2 to the power of negative 1/2 to base 2? Well, that's just negative 1/2. We should raise 2 to the power of negative 1/2 in order to get 1 over root 2. Okay, so that is that completes our practice, which should help solidify the definition of logs.